All right, now I said on the test, that's all I'm going to make you do right there. But just for fun, let's actually do the proof. What are we trying to do? It says prove that the segments blah 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 are what at the very end of 19. What's it say? Prove that these segments are congruent to each other. So I want to prove that this blue line right here and this blue line right here are congruent to each other. Well, I've got midpoints. I've got endpoints, don't I? Okay, I shouldn't say midpoints. I've got endpoints to this blue line right here. And I've got endpoints to this blue line right here. So what can I do if I know 2 points to show that the segments are congruent to each other? What do you think? Find the what? No, not slope. I'm trying to find that the segments, the length of the line segments are equal to each other. What am I going to use? If I want to show that this is equal to this, and I know the endpoints for both of them, I'm going to do what? Use the distance formula, okay? Use the distance formula. So let's do this one right here. We didn't really label it. Let's just label it, I don't know. We'll call this A, B, C. We'll call this X and Y. Is that all right? So let's find BY right now. So let's find the length of BY. So let's...
So instead of numbers, you plug in the letters.
That's right. Exactly right. And all I want to do, listen to me, all I want to do is show that this distance is equal to this distance. It can come out to some ugly, crazy thing, all right? But all I'm trying to show is this BY is equal to what? CX. That's all I'm trying to do, is just show that they're equal to each other. And how do I do that? I do that by the distance formula, okay? And that's our proof, okay? If you do that, that's our proof. That's the only thing about this that you have to prove. So let's do it. Well, we do this, right? And we do this. This one's the easy one because you're subtracting from 0, right? So what do we have? We have 3a minus 0, which is 3a. And then we take 2b minus 0, which is 2b.
You can see it from this that they equal each other.
Well, you can, yeah, but you can't say that in a proof, though. You can't just say it's equal to each other. All right, so what do we get here? We get the square root of what? 9a squared plus what? 4b squared. And you can't really simplify that any further. So that's the length of by. Now, what do we have to do to prove that they're equal to each other? Find what else? Find the length of cx, or xc. You follow me? So let's do the same thing with cx. And put it in the distance formula. That plus that. Oops, there we go. All right, and cx, it's from here to here. So what do we have? We got 4a minus a, right? That's how you find, let's do the distance formula, right? Which is what? 3a. I'll just do that in my head. And then 0 minus 2b, or 2b minus 0, which is 2b. Check it out. It's the same thing, isn't it? So that's 9a squared plus 4b squared under a square root. That's what cx is equal to. That's the length of cx. And check it out. What are they?
Congruent.
They're congruent to each other. We just proved by using a coordinate proof that by is equal to cx.
But Mr. Hammer,
that's all there was to it.
You know how you wrote for both answers 9a squared?
Yep.
I thought it would be just 9a since you already squared the 3a.
No, I squared the 3 and I squared the a to get a squared.
But that wouldn't take the square to get the square.
Yeah, there's a plus. There's a plus in between here. You can't get rid of this. You can't get rid of these squares if you have a plus in between.
Oh, okay.
Okay. That's for another day. All right. Does that make any sense at all to you? All right. Let's try one more. Okay. We're on a roll, aren't we? Got a few minutes here. Let's try one more.
On a roll.
This is basically what we tried the other day, and I never did put it up on YouTube, just because I just didn't do a very good explanation. But I think we'll do a little bit better job here.
It's a scaling.
All right. So what we're going to do is we're going to take the midpoint of this side. We'll just eyeball it. Where do you think the midpoint is? About right there? Maybe about right there? Okay. And then we're going to connect it to the midpoint of the other side. So that's about the midpoint of the other side, isn't it? Well, what does it look like is true about this? And did I put a red line down here?
No.
I didn't, did I? Okay, well, let's do it then.
There's similar triangles.
All right, so let's put the red lion line. Okay. All right, there we go. So there's our triangle. What I did is I connected the midpoints of the two sides. You okay with that? So let's put some ordered pairs in here. I tell you what, let's label it first. We'll call this A. Now, for some reason, I called this C and this B, because that's just the way. And then this point right here is S, and this point right here is T. I just left a little room because I'm going to put some ordered pairs in here in a second. All right, you with me? So watch what we're going to do. Let's just label all these points that we have right here. This is the easiest one. Let's do this one first. What's that point? 0, 0. Okay. This one right here. Now watch. This is a midpoint, isn't it?
Yes.
All right. So, like from here. Like if I drop this straight down, now you got to understand this is not an isosceles triangle, so that doesn't mean from here to here is not the same from here to here, right? Because I never said it was isosceles. But let's do this. Let's say, yeah, I'll just make this I'll just make this 2a. Remember how we made this 2a?
Mm-hmm.
All right, so let's make that 2a 0. Now let's call this something though. From here to here, that really has no particular relationship to a, does it?
Oh, C.
All right, it's not like half of a or a third of a or 2/3 of a, is it? All right, because I don't know anything about the angles here. Let's listen, please. Let's not comment. Just listen. All right. Let's stop, please. Okay, so I'll say this is like 2b. Is that all right?
Cool.
So that point right there, I'll call that 2b or 2b0. All right. Now the reason I did that is because I need to find a halfway point between here and here. That's where this S is. Agreed? If I drop this straight down, wouldn't this be half? This is half of AC, right? So if I took from C and dropped it down, how do I get to this midpoint? Well, I go halfway this way and halfway up. So what's
Slope.
halfway this way?
B.
It's B, isn't it? Okay. And what's halfway up? Well, what's the whole way up? Well, let's use another letter because we have no idea how high it is. Let's use C. All right. So that's 2C. Then this, if I did a little dotted line here, what would this be?
C.
That would be at C, wouldn't it? So this point is what? Half of 2B, which is B, and then half of 2C, which is C. Do you understand why I made it 2B in the first place? Because it's a lot easier saying half of 2B is B and half of 2C is C. All right, that's the only reason. You could have made this B, but then what would this point be right here? It'd be B over 2, and then this would be what? C over 2. You got it? Then you got these fractions. You're still going to have fractions anyway, but that's okay. So what about this point right here? Let's think about that. Well, how far up did we go anyway? Like if I drop this to right here, how far up did we go? We went C, so that's going to be a C. What about this right here? Now watch.
It's the half point.
I'll tell you what, let's do this. Let's do this point. This would be better if we did this point right here. What's this point at C right here? Big capital C. It's what? 2B? 2C. Good. So that would be 2B, and that would be 2C. Are you following? All we're doing is trying to find out where these points are in relationship to A, B, and C. Now, what about here? Halfway between what? 2B and 2A. How can you do that? Well, if it's halfway between 2A and 2B,
You could be like 2B over
so
2C.
it's 2A plus, remember the midpoint formula?
Oh yeah. Oh yeah. X.
All right. Yeah, so you add the x's together, right? And then divide by 2. So what's that? It's just A plus B, right? 2 goes into that, 2 goes into that. So this is what?
A
plus B. What do you think of that?
Oh, I think that's weird.
Do you understand how you got that? Because look, I'm trying to find halfway between here and here. How do you find that? Remember we talked about going on a trip? Remember the first time we talked about midpoint? We're going on a trip. You're going to McDonald's or whatever, right? And here's the 2-mile marker. Here's the 10-mile marker. What's halfway? 10 plus 2, what? Divided by 2. Follow me? So what's halfway? It'd be 6. Same thing here. Look, where are you? You're at 2B here. Where are you here? 2A. How do I find the midpoint? I add them up and divide by 2. So 2A plus 2B divided by 2. That's your midpoint. And that's your halfway spot right there. So that's your point right there. That point is A plus B. It's a little different, isn't it? All right, and there's your points right there. Now, what are you trying to do here? We're trying to prove that this line right here is parallel to this line right here. We talked about this. What happens when you have two lines that are parallel to each other? What's true about their slopes? They're the same, aren't they? So guess what I could do to prove that this and this are parallel? I could find the slope of this line, then I can find the slope of this line. Does it make sense? Let's do this in a different color so it stands out. Let's find the slope of this one in the middle right here. So how do we find the slope? We're going to find the slope of ST. Remember how to find the slope? Subtract the y's, put it on top. So look, here's S and here's T. So subtract them. C minus C.
0.
Right, C minus C is 0, isn't it? Let's just do the bottom. So it's A plus B minus B. A plus B minus B. So it's what? 0 over A, which is 0. Okay, so the slope of ST is 0. I'll put that right in there. Now, what should the slope of this be if they're going to be parallel?
0.
It should be 0. Let's see if it is. So let's take this point, and let's take this point right here, all right, and find the slope. So the slope of what? AB, right? I'll tell you what. I'll just write the word out since I did it. Oh, stink. Sorry. Boom, boom. There we go. So watch. The slope of AB is equal to what? Subtract the y's first. The y's goes on top. So 0 minus 0, right? And then what? 2a minus 0. It really doesn't matter what the bottom is as long as it's not 0. So it's 0 over what? 2a is, what did I just show? I just showed that the slope of this was 0. I showed the slope of this was 0. So what must be true about line ST and line AB? They have to be parallel to each other. That's our proof. That's what we did for a proof. It's kind of like an algebraic proof, isn't it? It's just like, okay, well, here's these points, just plug them in, show the slopes are equal to each other. We did it. Boom. As long as I show the slopes equal to each other, that's my proof. On a test, I may not have you go that far. Okay, I might just have you just give these points. Give this point, this one, this one, this one, and this one. Okay? See those ones that are circled? On a test, I'll be okay if you just tell me the coordinates of those points. I'll be fine with that. Alright? Let me give you a little problem thing to do here. We're going to do the study guide, because remember, we're taking the test on Thursday.
What?
So I'm going to have you do the study guide.
Turn the homework in.
And I'll let you hang on to it until tomorrow, okay?
Do we still want to do 18 to 22?
Just
No.
on the 19 to 22, well, I already did 19, so 21 or 20, 21, 22, just set it up and do this stuff. You don't have to do the whole entire proof. Just find out those coordinates, okay? So, well, I did. If you look at the YouTube for the other class, I made them do that as well.
The other
So
class.
309 to
And I
312.
hope you're listening to this.
11 to 33, and 39 to 41. If that's a little bit too much to do, I mean, you can kind of spread it out between tonight and tomorrow night. I'm not going to actually collect it tomorrow, but we are going to go over these questions tomorrow. I'll collect that stuff on Thursday, all right? So you don't necessarily have to do all of them, but I would do as many as I could so that you know what to ask questions on tomorrow. All right, that's it.
Catch you later.